Welcome to INST 314, Statistics for Information Science. My name is Sean Jansen, and I'll be your instructor and facilitator as we go through this adventure together, learning statistics, R, and the wonderful world of data analysis. We're going to be offering these videos in what we call flipped class design. That means I'm going to be setting you forward with pre-recorded, bite-sized lecture videos that you'll watch before you come to class. And then in class, we'll work together reviewing the material and applying it with hands-on lab-style activities. So I hope you enjoy this course, and always I look forward to your feedback. This first topic, 1.1, is on data foundations. And in this video series, we're going to look at the foundation for statistical data analysis and its operating environment. Future videos will look at other aspects of statistical foundations. So let's go ahead and get started. What is data? Data is information about the world. It's all around us. We consume it every day. We generate it. We share it. Some say that we are in an information age. There's more data that's being generated, shared, and consumed than ever before. Now keep in mind, data's always been there. It's just that it's so pervasive and so instrumental in our daily lives. We see it all around us in different forms. It comes through as surveys, such as the General Social Survey, social media, like Facebook and Twitter, administrative records. These are things like birth certificates, tax records, or even just how many classes are you taking this term. Field records, when people go out into the world in the wilds, and that wild could be your very backyard, to find out interesting things like the number of cherry blossoms in a tree, or how far back has the ice caps receded this particular year. Laboratory records, where we find data in more controlled settings. We see these with things like drug trials, or even that psychology student who's come up and asked you to be a part of their study to find out how a particular color makes you feel. It's also more everyday. Things like, what did you eat for breakfast? Oatmeal? French toast? Maybe you're the coffee or tea person who doesn't actually eat, or maybe you're just too busy to eat at all. And so sometimes we'll also find that non-data, what I didn't eat, is just as interesting as the things that I did eat. So data, does it matter where it's coming from? It's all over the place and it's everywhere, but there's different types of ways we can distinguish data. There's primary versus secondary data. Primary data is data that is produced by you or collected by you. You are the person who is assembling it for its later analysis or archiving. Secondary data is second-hand data. Somebody else has collected it, curated it, put it together, and you are now receiving it. It's also possibly that you received it through a long line of second-hand individuals. Maybe somebody recorded the particular data, put it out on the website, and you were told by a friend of a friend of a friend. Still secondary, doesn't matter how many hands it's gone through. There's different types that we can look at data as well. Things like cross-sectional, historical, pooled cross-sections, and panel. What's the difference? Cross-sectional, we can think of it as taking a single snapshot, one moment in time, and we're going to look at everything in that snapshot. So if we were to go ahead and look at the first day back on campus and see what's going on in all the different classes with all the students, the staff, and the faculty, that one moment in time is our cross-section. Historical focuses on the individual or the one thing and tracks that one thing or one individual over time. Think of it like looking at a single company with a stock market, and you're tracking its performance throughout the day or even by the second. Pooled cross-section kind of takes a hybridization of these two. We look at a group of things, a pool of things, if you will, or individuals, and we track them through time. Now, these are not necessarily the same individuals or things. If they were, that would be panel data. So the difference between pooled data and panel data is that panel data is like a cohort, and you're looking at that same group over time. Where pooled, you can have, and most likely do, have different groups and individuals. Think of it like a survey that's offered every year, but you ask different people in that survey every year. That would be a pooled cross-section. The other kind that I want to bring up is what we call proxy data. Proxy data is when we're trying to look at something and analyze something that can be tough to quantify. If you ever ask yourself, what is happiness? What is stress? What is depression? These are things that we have a general idea that we kind of know it when we see it, but it's really hard to put into a formal expression. And sometimes then we find other things that we can characterize to take its place. Such as if you wanted to say how happy you are, we can look at it, how many times did you smile in a day? That might not be a very good proxy though, because some people might smile when they're nervous, or just as putting on a fake face. So proxies we have to be sometimes careful for when we see them and question them. Why are we worrying about data in the first place? Well, it's fundamental that we understand data so we can make our world better and to make good decisions about making the world better. We can do it for things like monitoring societal change in the US, keeping track of essential information, determining how or where to place ads every time you go to Google or Yahoo or Bing, and you're going to see advertisements pop up. Well, if we know your data, we can target things better to your particular choices. We can also find out different things like how different foods might affect my work. Maybe I find out that some things help me sleep better at night. So, one of the things that I just mentioned before was targeting data. This is becoming a massive, massive industry. Information is the new gold, if you think, or new oil, if you will. Just look at Netflix, a rising star in the entertainment industry. And when you log into your Netflix account, you'll find a curated list that's presented to you based on the things that you've indicated you've liked, the things that you might not have indicated you've liked, but you've been watching, as well as the typical things such as new releases and suggestions that Netflix is trying to put out. So when we're looking at statistics, what is it good for? We're going to find statistics used in all sorts of things, from commercial activities to science, social science, computer science, and engineering. When we look at commerce, what you just mentioned, things like suggested product placement, but we're also looking at fundraising and finance returns. How do we know when we send out those letters to please send us a donation? Well, we only have so many time and so much money to send out these suggestions, so we need to find out who can we target to best get our return. When you call customer service and they say, this call may be recorded for quality improvement services, chances are on the other end somebody's doing data analysis to figure out which calls need to be screened and selected, and when they find them, when is it something that's qualifiable to or for review. If you're looking in the sciences, would you really want to take a drug that hasn't gone through strict, rigorous statistical testing? Well, those side effects, they've got probabilities, and we want to know what they are. Climate change is a big issue, whether you believe in it or not, and there's going to be an array of statistics to support your argument for either side. Social sciences are obsessed with things like elections and policy spending, text analysis. When you look at a data to find out how many words or what are the messages inside of those, a lot of those rely on statistical foundations, or perhaps educational attainment. All of you are in college, and we all want to know what the payoff is going to be. Not only is there going to be a satisfaction of saying I earned my degree, but you're hoping that you're going to be able to get a specific type of job or a certain level of pay, etc. So we use statistics to help us narrow those things down. And when you look at things like computer science and engineering, many of you play video games, and underneath those video games there's an AI system and chances and probabilities of things occurring and how difficult something is set at. Cybersecurity is another rising field that we need to be concerned about. What's the chance that somebody can access into our systems? And design optimization. Everything that gets built, we need a way to figure out the minimal ways to have errors and issues and improve our quality controls. So if that's the case, the numbers speak for themselves, right? Well, perhaps. In some cases, or in all cases, the statistics underneath the data talk about their relationships. But the statistics don't do the reasoning for us. We still have to look at it and be able to interpret it and evaluate it. One of the things I really hope you get as a takeaway from this course is that you're not only going to be able to see the data, but you're going to be able to talk about the data, digest the data, evaluate the data, specifically for people who haven't taken a stats course or haven't taken it in a very long time. So you have to think of it that statistics are like power tools. Sure, you can go out and buy a chainsaw, and you might be able to figure out how to use it, just kind of tinkering around. But if you don't know how to use it, you could end up hurting yourself, and you could end up hurting others. Statistics are like that. You might think that they're just numbers, but just think of all of the different graphics, and we're going to look at some later, that show how the numbers could really be portrayed in a way that go against the actual meaning of what's there, or they could be seen and interpreted in a very odd way, and people will take those meanings and they'll run with it. The news media pundits do it all the time. Let's look at this slide here about the number of people who've drowned by falling in a pool and the number of films that Nicolas Cage appeared in. If you look at this graph here, you'll see that the two lines track each other pretty well. So you might think that there's a relationship. The more films that Nicolas Cage appears in, we're going to see more people drowning by falling into a pool. But we know better. Statistically, it may show that there's a relationship, but it doesn't hold up causally in real life. So the numbers don't always speak for themselves. We need to add a degree of context and real-world experience. So getting into the weeds then, we need to start talking about our terminology. You can't learn any discipline without having to learn its jargon. So the ones we're going to start with here are populations and samples. Population is any particular group that happens to have at least one common characteristic between them. Think of yourselves in this class. All of you are University of Maryland students. You might not all be a population of iSchool students, because this course may be attended by students who are not part of the iSchool, but you're all University of Maryland students, so that could be our population. We might be able to narrow the population to undergraduates, but I may have a couple graduate students sitting in here just for a refresher as well. So we have to think about what is that defining characteristic that outlines the population. And the sample is a portion of the population that we want to use to study that population. Going back to the classroom example here, if I wanted to know all about iSchool students, and that was the population of interest, and I was going to take you as the sample, I would have to know, are all of you iSchool students? Because if there are some of you who are not iSchool students, my sample might deviate a little bit from its representativeness. Just as well, if I wanted to know something about all iSchool students, and you were my sample, I also would want to try and do a good job of making sure that you were representative of the iSchool population as well. We'll talk more about what that means later. So, we just mentioned about the undergraduate possibilities, but let's look outside the iSchool. We can also think about AI bots on Twitter. What common characteristics do they have? Well, they're both automated, and they're both on Twitter. So they don't include people accounts on Twitter, and we aren't including accounts that aren't on Twitter as well, like Instagram or Facebook. But we want to think about the sample. So if that's all of the bots that could exist on Twitter, a sample might be just a list of randomly chosen Twitter bots from an account of known Twitter bots. Let's look at parameters and statistics, a couple more jargony terms that you're going to have to pick up. The easiest way to remember these are, look at the first letters. Parameters go with populations, and statistics go with samples. Parameter is a particular value represented in the population. It's a very precise value. It is a truthful number or truthful characteristic about that population. But the challenging thing about populations is that they're typically unknowable and uncertain. We don't often have population data. So the whole purpose when we're dealing with these statistics, specifically when we get to inferential statistics, is that we get the value from the sample that we call a statistic. It is representative, hopefully, of the parameter. And because it's from data we do have, we can measure it. We can estimate it with some margin of error. And we can say, obtaining the statistic that we have, how certain we are it is to the parameter based on some characteristics of the statistic, like its distribution and its probability, and things like that. So as we move through this course, I hope you will learn to develop your ability to recognize and understand opportunities that use data analytics to enhance decision-making. We're going to reinforce statistical intuition and to critically evaluate statistical studies. Remember, the chainsaw. Don't let the numbers speak just for themselves.